Today we're going to talk about measuring volume. When we measure volume of a liquid, we're going to use a graduated cylinder. The liquid in the graduated cylinder will have a curved surface, which we identified as the meniscus earlier in the unit. And we always want to measure at the bottom of the meniscus, so where this blue arrow is pointing. That's where we want to measure the liquid in the graduated cylinder. To measure precisely, we want to make sure that we're including a tenth place in our measurement, whether that's a 0 or maybe it could be 0.5, but we want to include a tenth place in our measurement. So if we were looking at the graduated cylinder shown here, again, we want to read the meniscus at the bottom, which is where the blue arrow is pointing. We would see that the liquid is above 30, and then we would count how many places, how many hash marks above 30 the liquid falls. And we have 1, 2, 3 hash marks above 30. Each hash mark in this graduated cylinder represents 1 milliliter. So when I measure the liquid in this graduated cylinder, I would say that it's 33.0 milliliters. That 0.0 is my tenth place. On the next slide, we'll have several graduated cylinders. We're going to read the volume in each of those graduated cylinders, and we want to be careful to make sure what kind of hash marks we have. Do we have whole number hash marks, as we had in this graduated cylinder, or do we already have decimal hash marks, which we'll see on the next slide. So here we have 4 different graduated cylinders. These appear in your notes as well. For the first graduated cylinder, remember we want to measure at the bottom of the meniscus. So the bottom of this meniscus is above 10, and we want to see how many hash marks above 10 it is. So we have 1, 2, 3, 4, 5, 6 hash marks above 10. Each hash mark is representing 1 milliliter because the next division is at 20. So each of these hash marks represents 1 milliliter. So 6 milliliters above 10 would be 16 milliliters, and we would want to write that as 16.0 milliliters. The next graduated cylinder, at the bottom of the meniscus, we are above 20. We're going to count the hash marks above 20. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 hash marks. Again, these hash marks are representing whole numbers because the next division is at 30. So if we're 9 whole numbers above 20, that would give us 29 milliliters, and we would want to write that as 29.0 milliliters. Moving on to the next graduated cylinder, the bottom of the meniscus is definitely above 7. Then when we count our hash marks, we are 2 hash marks above 7. This time, the next increment is at 8. So we can't be whole milliliters for every hash mark, because then we would have 8, 9, 10, 11, 12, 13. We are using decimal places, tenth places for our hash marks now. So this first line is 0.1. The next line is 0.2. Next is 0.3, then 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, before you get to 8 milliliters. So we are 7.2 milliliters in this graduated cylinder. Again, the hash marks in this graduated cylinder do not represent whole milliliters. They do not represent whole numbers. These represent decimals. In this final graduated cylinder, the liquid is above 1 milliliter. Again, we'll read at the bottom of the meniscus. We count 1, 2, 3 hash marks above the 1. We are not working with whole numbers, because the next division is 2. So between 1 and 2, we don't have any whole numbers, we only have decimals. So this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 before we get to 2. So we are 1, 2, 3, that's 1.3 milliliters. Remember, each hash mark here is a 0.1 division, so 0.1, 0.2, 0.3. So 1.3 milliliters. And there you have all of your measurements for those graduated cylinders. On the next slide, 4 more graduated cylinders will appear. You will read the measurements yourselves. I would ask that you pause the video and give yourselves about 3 or 4 minutes to read each of the graduated cylinders, making sure to write your measurement showing the tenths place. And then when you're ready, click play and the answers will appear. So here are the next 4 graduated cylinders. Go ahead and pause the video so that you can read the volume of the liquid in each of these graduated cylinders. Record your answer on your paper or in your Google Drive file if you're using Google Drive. And then unpause the video, play the video, and check your work. Okay, so hopefully you've paused the video. You have written down your answers for each of these 4 graduated cylinders. And here are your answers, so you can check your work. On the first one, I have 80.5 because we're halfway between '80 and 81. Again, we are halfway between 80 and 81. If you just had 80.0, I think that would be acceptable for now, until we get a little more familiar with the graduated cylinder. On the second one, I have 2.6. Again, on these ones, we don't have whole number divisions. We already have our decimals. So this was 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. The bottom of my meniscus, again, we're looking at the bottom. The bottom of my meniscus is at 0.6, so that would be 2.6. For the third one, I have 20.0 because the bottom of my meniscus looks like it's right on that line. The sides look a little higher, but remember, we read at the bottom of the meniscus. And finally, for the last one, I have 21.0 because, again, the bottom of the meniscus looks like it's right on that very first line, that whole number above 20, which would be 21. The sides look a little higher, but we're focusing on the bottom of the meniscus. All right, so please make sure that you checked your answers. If you got any of those wrong, please fix them on your paper so that when you study, you have the correct answers. At this time, you will get a practice sheet. On the practice sheet, you'll have several graduated cylinders. You're going to read the volume in each of those graduated cylinders. Remember that we're reading at the bottom of the meniscus. Please work quickly on this because we are going to go over the answers before the end of the period. The last 5 or so minutes, we're going to go over the answers to this practice sheet. So you want to make sure that you have answers so that you can just check your work to see how you're doing on this.